Okay, so last example for the shear strain, we will have a body that is submitted to a force, and the 3 points, the three corners are moving on X and Y, not only X, not only Y, on both of them. So that was our initial position, and the final. So let me put the letters. That will be point A, point B, point C, and let's say point D. Okay, and this is moving B there, C, a D prime, and C ups this way, something like that, and D prime. The question are, what is the shear strength of the 3 points? And they move on both, so we will have two angles to find for each of them. So what I found the easiest way to do it is like to look at the angles, to add the angles on with the horizontal line and the angles with the vertical line. So we will do that for each point. So let me give you some dimensions. Let's say this one is 100 and this one is 200, and it was a perfectly square. And now B moved to the right. Let's say it moved 5 to the right and 3 up. Okay. Uh, let's say C prime moved. I will put them right away. 12 and 10. This is all millimeters. Let's not put the unit. We don't need the unit. Okay. And let's say D move 4 and 2. Okay. Let me move the D prime a little bit there. Okay. I'm missing the prime now. D prime, and this one, the 2, is going to the left a little bit. So this is all the information that we have. Let's say we took a pictures of the body before and after the force apply, and we can record the exact locations. Question is, what are the shear strength in all of that? So let's start for point B. So we have, let me do for point B here. So we had A, and that was B, and now that's B prime. So we need to find the information in that triangle. This is this one. Okay, I will remove my yellow after so it doesn't get coded, but we are inside that triangle, and we try to find the angle. Oh my goodness. This one. Okay, that is the same than this one. So we try to find that angle that is the same than this one. So the distance on the top will be 5. This distance will be 5, and the vertical distance will be 103. So the angle gamma for the point B, or B prime, with the vertical will be A tangent of 5 divided by 103. And with the horizontal, so now we try to find the value with the horizontal there. Okay, so we need to be in that triangle. So for B prime, we have this one, this one, this one, and we try to find this second angle gamma there. So the vertical distance will be 10 minus 3, so this is 7. This is 10 minus 3 for this one. And for the total length, that will be 200 minus the 5 to the right and plus the 12 there. So that will be A tangent of 7 divided by, 207. Okay. And are they both positive? Do we both add them or do we subtract them? It depends of which quarter do we go. So this body is moving to the right and moving up in the quadrant number 1. So we are in that area, moving to the right and moving up in both quadrant 1. So both of them are positive, 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 so we add them together. So let me write tangent 7 divided by 207. That will be ups. Let me do that. Ups. I will make my little program very fast, and equal this one plus this one. So the first one, the value will be 0.0338. The second one, the value will be 0.04851. And it ended up being the total being 0.08231. Okay, let's go now on point D. I will explain you after why I do point D. Okay, point D. So now we are at point D. So oops, this is my A D prime, and this is my triangle. So we are in, let me do it in red. This is that triangle. I know sometimes it's, here we go. We are there, that triangle there. Okay, so it move up of 2 and 204 on the bottom. So this angle gamma that is with the horizontal will be A tangent of 2 divided by 204. Okay, and now the angle up. The angle up is with the with CD prime. Let's move that down. So we have D and C prime. Okay, let me do an angle there, like this. Like this. Okay, let me move that. Okay, so this distance on the top between D prime and D, so we are in that triangle there, or this one there. Okay, one of the sides. That will be the 12 minus 4. So this one is 8. This is the 12 minus 4. And for the vertical distance, that will be 100 minus 2 on the bottom, because it moved up 2, and it moved up plus 10. So that will be 108. So from vertical, the angle gamma, this angle gamma will be A tangent of 8 divided by 108. And this is plus, and this is plus, still moving both sides of the D prime is moving up and to the right in the quadrant number 1, so they are both plus. Let me plug that number. So for the first one, we say 2 and 204. Second one is 8 and 108. So first answer, it's 0.00980 plus 0.07394, and that gives us a final total of 0.08374. Okay. And now if we look at the point C prime, so ups we have B prime and we have C prime, and that was D prime, right? So what we can see is like the angle gamma horizontal is the same for B prime and C prime, and the gamma vertical is the same between, try to find another color, between C prime and D prime. So I repeat, gamma horizontal, same with B prime. Oh, okay. Let me change that. That was D and that was C, sorry. Gamma horizontal, B prime and C prime are the same. So that will be A tangent of 7 divided by 207. And gamma vertical is the same with D prime. So that will be plus A tangent of 8 divided by 108. So let's plug those numbers. 7 divided by 207 and 8 divided by 105. So first value will be 0.03380, second value 0.07394, and the total will be, so this is plus, and this is equal to 0.10774. Here we go. So I hope it makes sense. I think it's good to organize your angle that you found with horizontal and vertical. Found which angles are the same for points. Like in that case, B prime and C prime will be the same for the gamma horizontal. C prime and D prime will be the same for the gamma vertical. And don't forget to check your sign, your convention of sign that is provided. I hope it makes sense. Let me know if you have questions, and if you want to see how we can find that with SolidWorks, let me know. I will do a video, but just if you ask me. Bye-bye. Have a good day.